Good morning. 2.3 parallel lines cut by transversal. Same lesson as 2.2, except now we're going to throw a little algebra in here. Some algebraic expressions. So the first thing says which line or lines or segments are parallel. Okay, you can only go by what's marked on these figures, and you have to figure out, guys, that if this and this are marked for these two lines and this transversal, we'll put that, there's T, then those are alternate interior angles, and we know they're parallel if the lines are parallel, right? So if they're marked parallel, then I can come back and say they're parallel. Those are called converses. A converse of a theorem is, because I tell you alternate interior angles are congruent, that's the theorem I gave you. The converse of that theorem says,
at this time, I need the following students to report.
okay, so we got interrupted. So if the theorem says that if the lines are parallel, then the alternate interior angles are congruent, then the converse of the theorem says if those alternate interior angles are congruent, then the lines are parallel. So they kind of go back and forth with each other. That's why it's called the converse, the opposite, or the using the reasoning to give me the situation. So in B, I've got two angles over here marked as parallel. What if I ignore this line and ignore this line segment? These are actually rays or whatever from H up to F and E down through G. If I ignore these two, then I can say that this line, we'll call it A and B, are parallel because I've got this situation going on that lets me look at those alternate exterior angles as being congruent. That's also a converse theorem, okay? A converse of the theorem. All right, so here, what is the value of x that makes A and B parallel? This is where we're not saying they are parallel. We're saying if x equals something, then they're definitely parallel. Well, these are same side interior angles, right? So we know that they add together 2x plus 9 plus, what's that, 111, to equal what? 180. So if I take this is 120 together right here. If I take 120 from both sides, I wind up with 2x equals 60. And I divide that by 2, I wind up saying that x equals 30. If x equals 30, then those two lines are parallel. Okay? So this is basically look at their position, pretend they are parallel in that position, use that theorem to solve for the unknown. That's why it's a little different than just having transversals with numbers. Okay, these two angles right here, this angle and this angle, if C and D are parallel, then these two angles are considered to be corresponding, and they are add together to equal 180 or congruent? Congruent. So if I set them congruent, then I can solve for the W there, the variable, to make this true. That's all you're doing here. So if W equals 19, then these two guys should be congruent. How can I check that? If that's 55 right there, this needs to be equal to 55 also. So 3 times 19 minus 2. 3 times 19 is 57 minus 2. Is that right? 55 degrees. That's how you prove it. That's the proof. Putting it back in. If you're ever asked to prove that it's congruent, you got to put it back in to prove that those are equal. Okay? Second set of notes here. Like I said, we're just covering, this is all the same stuff from yesterday. or from the last lesson, but we're just adding a little bit to it. So here I've got two expressions that have an x in them and one that has a y. Now, I cannot set that y expression anywhere with that x and solve for both variables at the same time. I cannot do it. So you need to pick the two that have an x in them and determine their relationship. They're congruent. So if I put 9x plus 25 equal to 13x minus 19, put 9. Okay, so I'm going to start moving stuff around. I'm going to take that 9x from both sides. That's the first thing I'm going to do. And I'm going to add that 19 to both sides. I kind of do that all in one harmonious move. And I wind up with 4x equals 44. So if I divide both sides by 4, I'll wind up with x equals 11. Now that's great. But that doesn't give me my y. So now that I have one of those values, the x, which was the only one I could find to start with, I can take that x and plug it back in to something here that's going to help me get this y. Well, this relationship here between these two, they make a linear pair. Right here, 13x minus 19 and 17y plus 5 make a linear pair. So I can plug this x value right here into that and get 13 times 11 minus 19 plus 17y plus 5 equals 180, because that's a linear pair added together. This works out to 144 plus 17y plus 5 equals 180. So, hold on. Okay, so correction. 13 times 11 minus 19 is 124. Now, I'm going to combine these two like terms, plus 5 and 124, and get 129 plus 17y equals 180. So if I combine these two like terms, I get 129, bring down that 17y, bring down that 180. Now I can start moving things to the other side, like take this 129 from both sides, and I'll wind up with 17y equals 51. I'm going to write over my next problem. And when I divide both sides by 17, I wind up with y equaling 3. Beautiful. And I'm done. Because all this asks me to do is solve for x and y. Now, if it asks me to solve for a particular angle in there, I just plug it back in, right? Do a little substitution. Throw one of those numbers back in. If it asks me to solve for this angle, I do 17 times 3 plus 5, which is 56. If it asks me to solve for this one, I already did that right here, and it's 124. You ought to be able to answer any angle around those two vertexes given one angle. That's part of what we did yesterday in 12.2. 2.2, not 12.2. I don't know why I keep calling this 12.2. Okay, next question. So here we've got if they are parallel, solve for x and y. So it's assuming they're parallel. I need to pick out, I cannot start with this one and this one, because that's a y, that's an x. So the two expressions that have an x, their relationship is, they're not equal to each other. They are supplementary. They are same side of the transversal exterior. So they're supplementary. Consecutive is the word that you're supposed to learn with same side. Consecutive exterior. So if I take each of those x expressions, 3x minus 29 plus 6x minus 7, put them together, they should equal 180. So combining like terms, that's first move here. 3x and positive 6x make 9x. Negative 29 and negative 7 go together to give me negative 36. That's still equal to 180. Now, moving the number to the other side. adding 36 to both sides. I wind up with 9x on the left equals 216. Does that look right? Then I'm going to divide both sides by 9. And I wind up with x equals 20 what? 24. Okay. Now I got an x value. Woohoo! Now I got a choice though. I got a choice about what I can do next, because now I can look at that expression, that angle that has the y in it right here, and I could set it equal to this one, because those are alternate exterior angles and they're congruent. Or I could take this expression and add it with this one and set that equal to 180, because those two make a linear pair. But since I did that in the problem above, I'm going to set these two equal to each other in this problem, okay? But I want you to know there's a choice there. It's your choice, whichever one you feel more comfortable doing. So now, I'm going to set these two guys equal to each other, so I've got 8y plus 17 is equal to 6x minus 7. Well, I know that x is 24. I've already found that, right? Got this answer going over here. I can use it. So 8y plus 17 is equal to 6 times 24 minus 7. You can do that in your calculator. And that's with you subtracting the 7 from it. Okay, 137. So we still got this 8y plus 17 going on. I'm going to move this 17 to the other side, and I'm left with 8y equals 120. Now I'll divide both sides by 8, and I find out that y equals 15. And I'm done, because my question asked me to solve for x and y. So I'm finished at that point. Alright. This last one. I threw this one on here because it's kind of ugly and people kind of freak out about it a little bit. But let's not, okay? Let's not freak out. Let's look at it for just a minute and see what we can come up with in this problem. It says find the value of the variables in each figure and explain your reasoning. Now, I want to look at just the x's, and I'm going to color the x's red. What do I know about all three of these angles down here? They equal 180. So if I take those three angles, 2x plus x plus 90, and set that equal to 180, then I can solve for x. So we'll start off right here by combining like terms. 2x and x is 3x plus 90 equals 180. And I'm going to move this number to the other side and wind up with 3x equaling 90. I'm going to divide both sides by 3. So I just want to know what x is. I don't care what 3x is. And I come up with x equaling 30. Now that's great. So let's go back up here. If I know that this is x and it's equal to 30, and I know this is 2x, it's equal to 60. We're just going to put those in there so we've got them. Where do you want, these are our parallel lines. These are the two transversals. What is equal to 30? What? Okay, because the 2y and the 30 on this transversal right here, let me do this in purple. Here's this transversal, okay? And I've got this angle now right here, congruent to this angle right here, because they're alternate interior angles. You see that? You see where they're alternate interior? They're inside these two parallel lines, and they're on opposite sides of that transversal. Okay? So this 2y equals 30. That'll let me solve for y, right? So dividing both sides by 2, y equals 15. Alright, I'm nearly there. I got 2 of them. Now, if I go back up here, y equals 15. Well, 2 times y is obviously 30. We wrote that expression, right? So I know that this angle is 30. Does that make sense that those two are congruent? Now, I'm going to take this 30 right here, add it to z, and what's that going to equal? 180. So 30 plus z equals 180. Because these two guys right here make a linear pair. So if I take the 30 from both sides, what is z equal to? 150. And there's my final answer. So it's like a puzzle. Comes in like a puzzle. Looks like a headache. But don't flip out about it, okay? Just like these x's down here, I know there's 3 angles, but you know those 3 angles are going to equal 180 put together. It's not 2 angles that are necessarily supplementary there, but those 3 angles are on a line, so you can use that concept by adding them together to equal 180. Okay, so your practice. And when you put your practice in, this first page of your practice asks you just to solve for x. Okay, I'm not asking you to put anything back in and figure out anything specific angles. Just solve for x on the first page. On the second page of your practice, you have to solve for x and y. And when you pay attention to your Google form, please, because like problems 1 through 8, which are off the first page, will just have one answer. And then I started numbering again with problem 1, and it has an X and a Y answer, okay? So just pay attention when you're filling out your Google form. And you got to take a picture of the front and the back and put them into one submission box for your credit.
Okay.
Good luck, guys.